So, good morning, everybody. I will continue today on the lecture about Chapter 1, Introduction to Demography, and I stopped on this slide in the last class. But I just wanted to watch the course website. Some people said that they came here to the course website and tried to click on the lecture for Chapter 1. It did not open, but it is available already there. So if you click there, the slide should open. You can download as a PDF file. If it doesn't work, and when it shows a message as this file didn't exist, just press Shift on your keyboard and click refresh on your browser, and we just refresh, and you should be able to download the PDF here, right? The same thing might happen for the next lectures, because right now I did not upload for the other chapters. So for example, for chapter 10, the next one, if you click here, you're gonna get this message because it's still not there. So it doesn't matter if you press Shift and refresh, is not gonna get it. But this one should be there. Okay, this file here should be there since I uploaded before our class last Tuesday. In the syllabus, I also updated that the quizzes, they will be available on Canvas from 12:25 p.m., the time that we finish the class, until 8 p.m. the next day, in the following day. But the first quiz we're gonna have just after our third day of classes on exactly next Tuesday, right? So next Tuesday, we are going to have our first quiz, and it's gonna open at 12:25 p.m. that day. Cool. Yeah, I think it's the only problem that people had, and I also uploaded the video recording from the previous lecture to the YouTube channel, and I saw that some people already watched it there, and I will keep doing the same throughout the semester. Okay. So Grant, as we talked before, is considered to be the founder of demography. He used all this historical data from London, vital registration, about like when people were born and when they died. So he knew the ages of those people. He also knew places of residence. He also had information about sex, whether people were women or men. And with all that data that was already available there for a long time, he just tried to develop the first kind of demographic methods to analyze vital registration data, like data that comes from birth certificates and death certificates, and also information about people moving from one place to the other. And what he realized as a whole here, his main substantive contributions. He saw that there was a migration going on from rural areas to urban areas, but at that time, the mortality rates, they were still higher in urban areas than in rural areas. And nowadays, in our current society, what we see is the opposite. In urban areas, we usually have better socioeconomic status for the population. People have better access to health services, have more access to a variety of food, of resources, better habitation, and so on. And people tend to live longer in urban areas in contemporary societies. He saw the opposite at that time that he was doing that analysis. In terms of mortality by sex, he realized that, or actually the division of the population by sex, if he looked overall, the population in the area in London had pretty much the same amount of men and women. Why is that? Because the same amount of men and women are born and they die at the same time? No. What he saw in the data was that more men, on average, were born than women. So there were more baby boys than baby girls. So the male birth rate was higher than female birth rate, more boys being born than girls. And this is still true even for current societies. Usually we see on average 105 boys being born for every 100 girls. In some countries in which there is a preference for boys, such as China, Taiwan, and some other Asian countries, then you see even more boys being born than girls, around 120 boys for every 100 girls. In that case, because there is a preference for boys and people trying to limit their fertility, when women get ultrasound and they see that they are pregnant of a daughter, of a girl, there is a higher chance of them performing an abortion, right? But even in societies where there is no preference for boys compared to girls, biologically speaking, we still have more boys being born than girls. That's for some biological reason, more boys are born than girls, and there are several different theories behind it that we will talk throughout the semester. So overall, more boys than girls, even at that time in London. But he also realized that throughout all ages, men die younger, die faster than women. So in a specific age group, more men die proportionally in that age group than women, for all age groups, right? And the same thing we also see in our current society. Women live longer on average than men. So more men are born, but since women live longer, if we take the overall count of the population, overall you see around the same number of men and women in the population. And using all these different data from vital registration data and organizing the data by age by which people died, he was the first one to present mortality in terms of survivorship. So he is the person who started to create this technique now called a life table, in which nowadays we estimate life expectancy at birth, right? So this is an example of his life table. He pretty much, for example, had 100 babies being born in a specific year there in London, so age 0. By age 6, you had only 64 alive, so 36 died before reaching age 6. And then only 40 reached age 16. And you keep going, people getting older, dying, so fewer people survive until by age 86, everybody had died. There was nobody else from that specific group of 100 people that he had counted here. That's just an example to show how he organized that information. When in this case, you have the number of people dying from one age to the other, and you know also how many were born. And you have that information by age groups. With that, as we're going to see more specifically in the chapter about mortality, you can estimate the life expectancy at birth. What is the life expectancy at birth? For example, a country that has a life expectancy of birth of 78 years. If a group of people are exposed to the mortality rates of that society that were measured in that year, if a group of people were to experience those mortality rates throughout their whole lives, they would live on average 78 years. That's the life expectancy, right? And that we usually hear a lot in the media. I used Twitter, and I think it was actually on Tuesday, I think Elon Musk, you guys know Elon Musk, he just tweeted something about demography, and demographers just start to make fun of him, and I will show you some of these tweets in the next chapter that's more related to that topic. But he was pretty much saying, oh, if you just get the life expectancy at birth and multiply by the number of people that are born in a specific year, you can project what's the size of the population in the next years. But that analysis that he did in his tweet, and he was pretty much criticizing the projections by the United Nations. It's kind of funny, right? When you're really rich, You can be as arrogant as you can, and it doesn't matter, right? But so he was criticized. The United Nations has this history of doing population projections, but he doesn't realize, it's a basic thing that you all guys will know when you finish this course, is that if you get the life expectancy and just multiply by the size of the population at the beginning, you're not taking into account that these mortality rates can change over time. They are not constant, as he assumed in his simple calculation, right? Life table, in order to get a life table and estimate life expectancy, and then after that, have many more indicators to do projections of the population to the future, you need more data. You need to understand the changes that the society is passing through. Mortality is not stable over time. And a major thing is the pandemic right now, that for the first time every so many decades, life expectancy has dropped in the US because of the pandemic, right? So we have to be careful whenever we talk about these indicators in demography. If we are rich, people can respect us, but those that know a little bit knows that they're just full of. So we just have to be careful whenever we analyze demographic data. And that goes back to the 1600s, right? I'm not gonna make you read all these old demographic methods books or anything, no. But we have to understand the methods in order to make quality analysis of what the changes in fertility, mortality, and migration mean, and how we can use that data to project populations to the future. And another set of contributions by Grant was more methodological. He paid attention to quality of data. That's a huge concern of demographers. We just don't get the data, and whatever result that we get from it, we report it publicly. We usually try to see if there is an issue with the data. We try to correct the data. The US Census Bureau, whenever it conducts the decennial census, the last one on 2020, and also the American Community Survey, the American Community Survey has more questions every year. Before they release the data that they call actually the population, they go back to the questionnaires, they go back to the database and see if there is an inconsistency, they make corrections. They pay attention to the quality of data. That's something that has been done by demographers for centuries. Exhibit a healthy skepticism. If something that he found was completely different than what was found before, he was just a little bit careful. Let's try to analyze that data again. Let's try to use another approach to see if we reach the same result. If that result is contrary to what we saw we have from previous studies. So always questioning the validity and reliability of data is important among demographers, and that comes even from since Grant. So just going to the textbook that we use here, so Dudley Poston, he explains what demography is in a really straightforward way, and this explanation is the one that's available, that I included in the course syllabus. Demography is the scientific study of the size, composition, and spatial distribution of human populations. So I want to know how many people are there, the size, but I also want to know how many men and women are there. I also want to know how many children, young adults, and older people are in that population. I also want to know the race ethnicity composition about that population. I also want to know the socioeconomic status of that population. How many people are poor? How many people are in the middle class? How many people are rich? And I want to know all this information, combining all these variables together. Right? What's the percentage of women, adults, higher educated, who are married and have in the middle class, for example. So all these questions about sex, age, marital status, race, ethnicity, composition, education, socioeconomic status, all these different variables explain, give to us information about the composition of the population. And that's actually also important for demographers. We just don't want to know the total amount of people. We want to understand the characteristics of those people. And we also want to know where they live, where they are located, spatially speaking, like geographically speaking. Is the population randomly spread throughout the US? For example, the same number of people live in the East Coast and the West Coast and in the middle of the country? No, we know that specific big cities, they have a bigger population, even compared to the size of the area, and fewer people live in the middle of the country. Why is that? What are the historical reasons that make that happen? So all these things, why people are concentrating in specific areas. What have been the trends of people moving from one area to the other? This is related to migration. This is related to geography as well. And you see that the composition, we talk about a series of different aspects there. Socioeconomic status, you're talking about economics. You can also break down the population by ideology. You're talking to political science. You can also break down the population by what are the causes of death that people are dying. That's related to public health, right? So you have, and just now I said spatial distribution is related to geography. So demography is really interdisciplinary. That's why usually in the US and around the world, you don't have pure graduate programs in demography. It's usually related to a specific discipline, and then you have people from other areas as well. UC Berkeley, UPenn, they do have demography programs specifically for graduate programs, but usually they are within other areas, exactly because demography is so interdisciplinary. Demography investigates changes in population size, composition, distribution, and all these changes that happen in our population are related to how many children people have, fertility, how often people die, and what are the causes of people dying related to mortality and morbidity, and where people move to and move from, both within countries and between countries, both internal and international migration. So the three components of demography, they are all associated with changes in the size, composition, and the spatial distribution of the population. Demography helps understand what the past says about the future, giving expected population changes. So yes, we do look at historical data and trends in fertility, mortality, and migration to kind of project the population into the future. We don't do a silly exercise multiplication that Elon Musk did. We do more a complex analysis. And we look at historical data. We look at these historical trends and levels of mortality, fertility, and migration, okay? And this is just a really simple graph. I just got it from this website here, populationpyramid.net. It has a lot of like interesting graphs that make it easy for us to understand demographic indicators. In this case, it's just about the size of the population. So the size of the world population around the year 2020 was around 7.8 billion people. And here the size of the squares and rectangles are proportional to the size of the population. And then you see China and India really big, and the colors are related to the continents, right? So you have Asia in blue, Africa in orange, and so on. But then you see how population size is not completely related to economic development, is not related to economic growth, because some countries that have much bigger population size, they have worse levels of development, more people living in poverty than developed countries. And I just like to see this graph just because, I mean, if you compare USA to Canada, and I always compare the size of the Brazilian population to the Argentinian population because I'm a huge fan of football, the real football that you guys call soccer. And Brazil and Argentina has this huge rivalry. And I always look at population in Brazil, we are like around 230 million people right now, and Argentina is always around 30 million people. So at least like they might win some games, but we still are bigger than they are. So that's the way that I kind of like make some thoughts about that. It's just so interesting how rivalries is not really related to population size. It's a historical thing. And you guys have that here with UT Austin, for example, right? So it's so interesting to see that. It's not about population size. It's about history. It's about all these events that happened in the past. So the concerns of demography is not just related to population size. It's not just related to population growing or declining in size. We want to understand all components, all processes in demography: mortality, fertility, and migration. What's the level? Is it high? Is it low? What's the trend? Has been increasing the number of children that women are having, or is it declining? Mortality, same thing. Migration, the same thing, right? Where people live. What's the population structure? Whenever we talk about population structure, we usually are talking about the age and sex structure of the population, the size of the population in each one of the age and sex groups, right? So that's the one that we get the population pyramid. But you could also include all the variables to analyze the population structure. Population characteristics, then you go further into those other variables that I mentioned: socioeconomic status, marital status, political ideology, race, ethnicity, and so on, okay? So this is just repeating some primary demographic questions. How large or small is the population? How is the population composed in terms of age, sex, race, marital status, and all these other characteristics? How is the population distributed in space? Because we know that people don't have the same chance to live in all different areas. Within a city, within a state, within a country, and throughout the world, people concentrate in specific areas. How population changes happen over time. And that's interesting, because if we know the trends over time, then we can do meaningful projections about the population, right? We can try to see what is changing, what we expect to change the next years, and then we can expect to see how the population is going to be, both in terms of size, but also the composition of the population. We see, because of international migration into the US, and more recent ones from Latin American countries, but also from Asia, that changes the composition of the American society by race, ethnicity. And also, and also fertility of specific race, ethnicity groups are higher than the others. And all that makes changes to the composition of the population by race, ethnicity, for example, right? And all that is important to understand, and we have to get data changes over time. So these demographic questions are answered in terms of fertility, mortality, and migration, which are the demographic components or demographic processes. And so here I kind of like give you an overall conceptualization of what demography is and what's going to be our goal throughout the semester, okay? So just starting here, I will just show you the demographic equation that shows population size and how population size can change over time. Population size can only change through the influence of the three demographic components: fertility, mortality, and migration. People enter a population, then population grows through fertility, people being born, or people getting out of that place, going to another place. Right? Either moving, if you're doing the analysis of a specific city, moving out of the city. Analysis about the state, moving out of the state, and so on. Oh, I just said the opposite. You can correct me when I say something wrong. I'm talking about two ways of entering a population, either people being born, fertility, or people moving in, right? So when there is in-migration, or when there is immigration. In-migration are people moving from a specific area from the same country. Immigration, people moving from other countries to this one that I'm analyzing. So the size of the population where I am grows when we have more kids and when more people move in. And the population declines in size when more people die and when more people move out. Population can only change by way of a limited, countable number of events. So when you try to organize how the population size can change over time, and you try to simplify that, but capture the complexity of the aspects of the components, it's a way to try to understand how your society, how you expect the population to be in the following years. So this is the basic demographic equation. Here we have the population in a specific time point. I'd say the time zero. Let's say we were in January 1st, 2021. What was the population in the US? How many births happened in the US between January 1st, 2021 and December 31st, 2021? This will add up to your population. How many deaths happened in the US between January 1st and December 31st last year? That will take out from the size of the population for the next year. How many people entered the US as immigrants, as international migrants between January 1st and December 31st last year? And how many people left to other countries in the same period? People moving in, they add, people moving out, they subtract. And the result of that, based on data from the last year, we know the population in the US in January 1st, 2022, okay? In this example here, I'm talking about, I'm trying to understand the population in the US. If I was talking about the population in Texas, people moving in, they can be either international migrants, immigrants coming from other countries, or they can be people moving from other states in the US to Texas, internal migrants or immigrants in this case. And these people leaving, if I'm talking about Texas, can be either people moving out of Texas to other countries, international migrants, immigrants, or people moving from Texas to other states in the US, internal migrants, in this specific case, out migrants, right? So this basic demographic equation might give us an idea that fertility, mortality, and migration are the factors influencing the growth or the decline in the size of the population. The problem is that the exact number of births that we expect that people will have in the next years, the deaths that people will have in the next years, and if we break that down by age, is even more difficult. Now, during the pandemic, mortality increased a lot compared to previous years, compared to years before 2020, that were not expected. So the population projections might be a little off because nobody was expecting the pandemic in 2020. And the pandemic also affected international flows of people between countries, because some countries closed their borders or are much more restricted in terms of requesting vaccines, requesting COVID tests, and so on. That makes less people move from one country to the other. Projecting more migration to the next years among the three demographic components is the most difficult one. Fertility changes over time. right? And now has been declining, changes over time. Now, because of the economic recession that we experienced just now during the pandemic, people tend to have fewer children, postpone having children. But it's kind of stable over time. Mortality, the same thing. Yeah, more mortality now. Mortality rates increase now in these last 2 years, but it was kind of stable in these last few decades. If you're talking, for example, about the US. We also had the opioid crisis. We have the opioid crisis here in the US. I will talk more about this later in the semester. That also caused some increases in mortality, unexpected increases. But overall, fertility and mortality, they oscillate much less than migration. Migration can be affected by changes in really a daily public policy that's implemented by a specific administration. If a specific administration wants to is against immigration and so on, and make some changes to immigration laws, that can affect either increase or decrease immigration. And we're going to talk about that later in the semester, that these policies that increase border security, for example, in the southern border in the US, they usually have the opposite effect as intended. They actually increase the number of immigrants entering the country because these immigrants enter and don't leave. So it's a complete waste of tax money. If you take into account science, it's a really waste of public money. Migration then is already difficult to measure over time. So whenever we do projections, our major challenge, if you're doing projections for countries, states, is try to think what are the future scenarios of migration, both in migration and out migration, right? And with the pandemic now, that affects even more. And whatever major you guys are studying here in the university, whatever science you are doing, whatever thing you are planning to do as a job in the future, always the thing that we always try to understand or try to think is, can I see what's going to happen in the future? Right? Always when you try to understand the past and try to understand the present, is to implement some changes, some improvements that will benefit the society in the future. And we also think about, if we don't do anything, what's going to be the society in the future? If we do, and it doesn't look good, so let's try to change something right now to improve the society in the future. So thinking about the future of human society, it's a major goal in any one of our interests, right? And in the case of demography specifically, is exactly related to population projections. But population projections, like I said, fertility and mortality might be more stable, not as much now in the current context, but migration was already difficult to put into this analysis. That's why we usually have all different scenarios of what we think is going to happen in the future. And we don't do only population projections for that state or that country as a whole. We try to break it down, at least break it down by age and sex, age groups and sex. And some more refined data, if you have more refined data, you can break down by all the characteristics of the population. But usually we do projections breaking it down by age and sex, because then you can see how the population is going to look in the future, and you can try to implement some policies to benefit that future population, right? So foreseeing the future is an overall goal that we all have here, right? Either some people want to make money, and other people want to focus on improving the world, right? And just looking at the specific components, the specific subcomponents of the basic demographic equation. If in a specific year, specific time point, in that example here, births and deaths between January 1st and December 31st, 2021, we had an overall more people being born than die. So if you have higher number of people being born than die, you have natural increase. If you have more people dying than being born, you have a natural decrease, or is also called a negative natural increase, So you either have a natural increase or a natural decrease. This term, natural increase and natural decrease, this term in demography, takes into account the effects of only fertility and mortality. Migration is not taken into account whenever you're talking about these terms. Whenever you hear someone say, oh, the natural increase rate in this country is this one, and that other country is actually negative. So we have a natural decrease of minus 1% of the population per year, really big. But you know, natural decrease and natural increase, when someone talks about it, is just related to the effects of fertility and mortality, not migration, okay? And what about the components of migration? You can also see, based on the in-migration trends and the out-migration trends, you know, you just subtract the number of people entering that specific area by the number of people leaving that specific area. And this subtraction is called, if I'm talking about people moving between countries, is the net international migration, is the immigration minus immigration. If I'm talking about people moving within countries, I'm talking about net internal migration, in-migration minus out-migration. If the number of people entering a specific area is smaller than the people leaving that specific area, you have a negative net international migration if you're talking about people moving between countries, or a negative net internal migration. These countries that receive less than they lose people are descending countries, countries that send more people to other countries than receiving overall. So they send more people than they receive. And if you're talking about internal migration, these are areas within a country that have net out migration, people getting out more of those cities, states to other areas within the country. And if you have, on the other hand, an area or a country receiving more people than losing, if you're talking about international migration, you have the receiving countries, which is the US, for example. More people move into the US within a year than people leave the US in that same time period. And the same thing, if I'm talking about a specific sub-area in the country, states or cities that receive more people than lose, those are net immigration areas, right? So with this really simple, basic demographic equation, we can already compare those components of births, deaths, in migration with out migration, or immigration with emigration, and see what the trends of the population are in terms of increasing or decreasing the size, okay? And now, this is from another textbook. It's a textbook about Introduction to Social Statistics. I just wanted to make sure that everybody understands these simple concepts of variables, observations, and database, because we're going to use that throughout the whole semester. So I was talking here to you that one of the concerns of demography is to understand what are the characteristics of the population, break down the population by specific characteristics, socioeconomic, demographic characteristics. These characteristics are variables, right? If I ask someone the age, the sex, the race, ethnicity, the answer for that person probably will be different than the next person. And of course, I will get all the variation that I have in that population if I ask everybody. So variables are the characteristics that I collect from my population. Can be gender, age, race, and ethnicity, number of children, place of residence, income, and so on. The observations or the cases are related to who I'm collecting that data from. These observations or cases are also known as the unit of analysis. I'm collecting that information from individuals. I'm asking you your gender, age, race, ethnicity, number of children for each one of them. I'm doing this analysis at the individual level. If I'm trying to understand the overall demographic changes that countries are passing through. So I can get total fertility rate for all countries in the world, life expectancy, net migration rates. In that case, my variables are these three that I just mentioned: total fertility rate, life expectancy, and net migration rate. And the observations are countries, right? So each case in my data will be a country. I could do that for states. I could do that for households. In households, instead of having questions for each single person, I can just ask, oh, how many people live in the household? What's the overall income of the total income of everybody here in the household? How many bedrooms you have in the household? Do you have TV? How many TVs do you have? And so on. How many cars do you have? Do you own this house or not? So that information is at the household level. And the characteristics are these I just said, characteristics about the household itself, right? So just going a little bit more, variable is a characteristic whose value varies from one case to the other, and we can quantify it. The idea is that we collect that information and we quantify, we give it a symbol, a numeric symbol for that one. So if I'm collecting information about by sex, men and women, I could apply 0 and 1. If I have information about race ethnicity, the same thing. I could do 1, 2, 3, 4, 5 for each one of the race ethnicity groups. These are nominal variables. They don't have an order, but I can give them this numeric characteristic, these symbols, the numbers that I can put in my database and continue and do my analysis. Usually we can divide variables in two major groups: the dependent variables and the independent variables. The dependent variable is a variable that is the result, depends on changes that happen in other variables. These other variables, the independent variables, are the ones who influence, which influence the dependent variable. So let's say that my intention in a specific study is to understand levels of income of a population. And I want to know how much more or less people earn money in their income based on a series of independent variables. So income is the dependent variable. Which variables influence my income, my dependent variable? Give me examples of independent variables that I could use in my analysis here. Sorry? Your job. Depending on the job that you have higher income. Education, people go to college to get better education. And you get better education, then you have higher earnings. The location where you are, maybe specific locations, you do the same job as in another place, but here you make more money. That's the case of, for example, international migrants that move, for example, from Brazil to here, doing the same job. Here in the US, they make more money. Number of kids that you have, usually people that have more kids, that has impacts negatively the amount of money that you have to invest in their education, in where they will live, and then that can decrease the amount of money that you have and that your children will have also in the future. You with the brown jacket? No? I thought you, yeah, not, okay, good, sorry. Okay, good. Age, right? Usually people between 30, 55 years of age are the ones that make more money, right? After they get some experience in the labor market, and then after they retired, earnings go down. Race, ethnicity, historical reasons, discrimination, racism in the US, really varying levels of income in the country by race, ethnicity, controlling for all that. Controlling for all that. Same job, same education, same number of children, same location, same race, ethnicity. On average, women receive less than men. Sex is also important, right? So these are all, there's just an example of independent variables that can help you explain the dependent variable. It has to do with sexism, it has to do with racism, it has to do with qualifications when you're talking about education as well. It has to do where you decide to live. It has to do with your fertility, right? So all these aspects are important for us. Whenever I'm trying to understand a specific topic, in this case, earnings, I need to collect information about that population that will try to give me the more complex and in-depth picture, okay? When we try to say like this specific variable is responsible for changes in the dependent variable, what I'm trying to do is an analysis, it's a causal analysis, right? An analysis of causation. And in that case, I have previous studies, historical studies, previous studies that were done about that specific area that tell me what I should expect it to be. All these things that we are thinking here about what are the independent variables that would help us explain variations in income, our dependent variable, did not come up from our head. That's because we know the US, right? We know historical patterns, things that happened in the US in the past that make the US what it is right now. So we do a literature review, we look at previous studies, what previous studies told us that are important to explain our dependent variable, and then we collect information from the population, collecting both dependent and independent. And we already have an idea of what these variables will be. We expect that people with higher education have higher earnings. We expect that people living in certain locations have higher earnings, controlling for all the other variables. We expect that people with specific jobs have higher earnings. We expect that men have higher earnings than women, not because they're better, but because of sexism in the labor market, right? And controlling for all the other variables. African Americans have lower earnings than white Americans. Controlling for all the other variables. That's racism, that's discrimination, that's the history of the US, right? So the previous studies that did all this analysis that help us explain what we are trying to understand, these are kind of theories. They are theories. They are series of understandings and knowledge that we have about our society that help us understand our research question. These theories give us preliminary answers to our research questions. The preliminary answers to our research questions using theories are called hypotheses, right? We use theory, and with this theory here, these previous studies that were already done in several different areas, by several different authors, they give us an idea of what to expect about the dependent variable. And those are hypotheses. Whenever you usually watch the media, here in the US, people use the term, oh, I have a theory of why this is happening. The correct term, no. It's not you have a theory about what is happening. You have a hypothesis about what is happening. And your hypothesis is based on the previous knowledge that you learned, right? So the preliminary answer to your research question is the hypothesis, which is based on theory. And the main idea is to understand what are the causes, what are the independent variables, that explain the dependent variables that result in the aspects that we encounter in our society nowadays. These terms, dependent and independent variables, is the one that usually is more used throughout the literature, but you could see other names as well. So these other names, you could see them, but they mean pretty much the same thing as dependent and independent variables. In social sciences too, if we have one independent variable that we will focus the analysis, we call that one independent variable. And we call the other ones, we are controlling, we are putting them in the analysis, but we are not really focusing on them. We call them control variables. But all of them are independent variables, okay? And observations, like I mentioned, are the cases collected about each one of our, from our unit of analysis to test the hypothesis. Hypothesis based on theories. We have to decide how variables will be measured and how cases will be selected and tested. We have to measure social reality. We have to measure social reality and transform it into numerical data. For example, I always remember in my undergraduate course, a professor was talking about, I was in a course about theories, sociological theory. He was talking about social classes. If you understand social class, what is a social class? Oh, I just saw outside the window there, a social class. Let me go talk to the social class. It's not that. The social class is the characteristics of specific society that divides it in all these different groups with different characteristics. So I have to think about a way to measure social class. Is social class only defined by income? Only defined by education? Only defined by race, ethnicity? What is social class? How do I define social class? How do I measure social class? And whenever I have a variable that I want to collect information, I have to think how I will collect it. And there are several ways to do it, okay? There are several ways to do it, and you have to go back to the literature and see which one is more reasonable, has been done in a more frequent way, it has been tested many ways by different researchers. When we collect this information, just think about your questionnaire. You're asking people, let's simplify, the unit of analysis being individuals. You ask the people what are their sex, age, and education, right? Questionnaire with 3 questions. How, after I collect that information from everybody, how do I organize it in a database? So the variables will become my columns in my database, and the observations will become my rows. And it will look something like this. This is an example from another textbook. In this case here, 526 workers were interviewed. So we have 526 rows. We ask the salary per hour that worker makes, how many years of schooling. And here, years of schooling is measured, how many, I'm not asking if you have a high school degree, a college degree, a graduate degree, or if you're a high school dropout. I'm asking number of years of schooling. So that was a decision, methodological decision that I did in order to measure education. Years of experience in the labor market. Some people prefer to use the variable years of experience in the labor market. People prefer to use years of experience in the labor market instead of just age. Because some people might start working earlier ages than others. So if we have the possibility of asking that, we can just ask the people years of experience in the labor market. Both of them, education and experience, we expect them to have effects on earnings. Sex. Let's classify in this case here between female and male. In this case, the variable female means 1 is woman and 0 is man. Marital status, let's just simplify it. There are several different marital status. Let's simplify in this example here. Married are 1, and 0 all others. I just want to know if married people overall have higher earnings compared to the other marital status, controlling for education, experience, and sex, right? So this is how the database looks like. I just gave you an example here about how could be a questionnaire in which we could ask age, what did I say? Sex, age, and education. And if I just ask for a series of people, their sex, age, and education, I can create a database like that one there. And I was planning to show on Excel, but it's just taking a while. So the information for each individual will enter in the row, and the variables will be the columns. So my columns will be, in this case, sex, age, and education. And for, let's just do it, and here I can have the ID of the person. That's the first person, second, third, fourth, fifth, and so on. And sex, let's do 1 or 2. So this person, let's say that's a woman, so that's 1. This one is a woman as well. This one is a man. Age, this one has 24. This one 37. And this one 35. Education, let's not do years of education. Let's do like this. My variable education would be 1 for less than high school, 2 for high school, and then 3 for college. Can be all different ways, because I could do some college separated from college, but here I just want college. So you guys would still be in high school if you don't have a college degree still from another place. 4, some sort of graduate school. So this one here is the way that I decide in this example how to quantify education, right? That's my education groups here. This person here is in college, but didn't finish college, so high school. This person here is in graduate school, but didn't finish graduate school, college. This person here is already working and has only a high school diploma, so 2, right? So I'm creating my database. I have 3 people that I collected information. Each one of those here are 1 questionnaire. Oh, and I also have to explain, right? Age is kind of simple. We know what 24, 37, 35 mean. But sex, in this case, I have to say it's female in this example, and 2 is male, right? This part here is my database. This part here is what's called a code book. It can be a file in Word or anything. It's just a file that explains your variables, right? This data here is called a micro data. It's micro data because you have each one of the variables for each one of these individuals here that are collected over time. From this sample that I have here, what's the proportion of men and proportion of women? If I wanted to do a table like this, here I want to have female, and here I want to have male, and the total size of my population, and I have here the frequency, and I have here the percentage. How many women I have? 1, 2, right? I know by the code book here that I have 2 ones, so I have 2 women. And I have 1 man. So in total, I have 3 people. And what's the percentage? I just divide it, and I get the numbers. I can just stop this one here to don't vary. 66.6, and then the 33.3. And the total is the same thing. In this case, it's going to be 100%. This data here in the top is my micro data. This one here is my aggregated level data. So when you go into different sources of demographic characteristics, some of them you might be able to get microdata. Others, we already have the aggregated level data available to you. So in this case here, you're going to have already the tables done to you. The advantage of this one here is that you can create your own tables. You can say, what's the average education among women? What's the average education among men? What's the average age of women? What's the average age of men? How do you do that? You use a statistical software to do that if you have a big database. I'm talking here about like millions of observations, millions of lines, millions of rows, and hundreds of columns. So for that, you don't do by hand like I just did here. You use a statistical software. For example, in sociology, we have a course, Sociology 420, that's Advanced Methods for Social Research. That's where we teach this. But you can already find this data already organized at the aggregated level data. And a lot of those links that I put in our course website, they already provide aggregated level data, so you don't have to do your own. You can get tables already organized. You can get graphs, maps, all sorts of things, right? But this is just to explain that how the data is collected from people. You first collect people, how many children they have. You first collect information about what age people died, and you collect information from where to where people moved. You get the microdata, and from that, you go into the aggregated level data, okay? And you organize the microdata. Columns are your variables, rows are your observations. Your unit of analysis in this case are individuals, the 3 individuals that I asked my questionnaire to them. I have my code book right here that explains what are the codes of these specific variables. Age, we don't need that. And I have a first frequency table, here for the variable sex. Cool? So that's how you can think about the data. And what we usually try to understand are associations between variables, right? This correlation between variables. And we have to be kind of, I used the term causation in the previous slides there. We have to be a little careful about the word causation. This variable causes the other. Because in specific time, this variable might cause changes in another one, but in a specific time point, or at the same time, this variable might have consequences on that one. Example, migration and earnings. You could say that if you have more immigrants coming to the US with low skills, you could say, oh, they will compete for jobs with low-skilled US-born people, and then the US-born people will have negative effects on their earnings. So that's immigration affecting earnings. Most of these studies don't find that conclusion, but that's a perception that we usually have. But in this example, migration affecting earnings. But the level of overall economic development in earnings that the US has compared to other countries make people migrate here more, right? The jobs that are available to people here, the jobs that are available to people, the opportunities that they have, earnings overall attract migrants. So in that case, earnings are the independent variable explaining migration, the dependent variable. So in that case, you have reverse causality between earnings and migration. In this example, when you have reverse causality, you have to be careful to don't use the term causation. You have to use the term association. There is an association between the variables earnings and migration, but I don't know which one causes the other. fertility and education. So usually women who have higher levels of education have lower fertility. And at the same time, women who have lower fertility have more chances to go to school, and then their daughters will also go to school. When I say school, is college degree, graduate degree. And that will affect later on the chances of them having, again, fewer children and have higher education. And then having higher education will make them want to have fewer children. So in this example is fertility and education. Fertility explains education. Fertility of the mother explains education of the children. And then education will explain your fertility later on. Okay? So whenever you have reverse causality, when the independent variable causes the dependent, but then in other cases you see the other way around, you have reverse causality. So be careful to don't use the term causation, impact. That's an effect of the other. That's the cause of that. You have to say that there is an association between migration and earnings, between education and fertility, okay? So all these terms are important for us to understand. One example of a database in the current context. This is an example of a database. What's the unit of analysis here? It's hard to read, but I think you'll understand by the title there. You have countries in the rows: US, Brazil, Mexico, India, UK, Italy, France, and so on. And in the columns, what do you have? You have the variables related to the coronavirus pandemic. And this table I collected from Worldometers, this website here. And at the beginning of the fall semester in 2020, and I've just ordered this database by total number of deaths. So it's ordered here by total number of deaths. At that time, August 24, 2020, the US had 181,000 deaths due to coronavirus, right? Brazil had 115,000. And total recovered, active cases, serious critical, cases divided by the population multiplied by 1 million, deaths divided by the size of the population multiplied by 1 million. The size of the population is here. Tests divided by the population multiplied by 1 million is here, right? So you have all, this is a database, but this is already outdated. What is interesting to see is changes over time. So let's just collect every semester at the beginning of the semester the same table. I mean, this one here, August 31st, 2021, beginning of the following fall. The US passed from 181,000 deaths to 656,000 deaths. That's the mid of last year. Oh no, but the pandemic is over. There's no more pandemic in the fall. And then between August, the beginning of last semester, until the beginning of this semester, I just got it on the 17th, 656, 874. Oh, only 200,000 people die more within this semester. So the thing is still going on, it's serious, right? So we try to understand, and all of them are ordered by the total number of deaths. These three, let's call them these three databases. That's a micro data if you are using the unit of analysis of countries. But you could also say, oh, that's already aggregated level data because you collected that data originally from the individuals, right? Dying from the pandemic in the US and all these other countries. So that could be seen as a aggregated level data. But in any case here, the idea is to show that that's how a database looks like. Rows have your unit of analysis, and variables, columns have your variables, the characteristics of that population concerning a specific topic that you want to understand. And then I got these 5 countries here, US, Brazil, India, Russia, and Mexico, that have the highest number of deaths by the day before our class started, this last Monday. And then I went to another website called Our World in Data, and I selected exactly these countries with more deaths: US, Brazil, India, Russia, and Mexico. And then I plot here number of new cases from January 2020 until now. And then we see all the different waves, right? In the US, like towards the end of 2020, it increased a lot. We were really concerned here. Right after spring break, we closed the university, and we reached this peak here by the beginning of the fall 2020, and all the classes were online. And then in the following spring, everything reopened here at the university, spring 2021, and the cases were higher. Wow, interesting how policies are taken, right? Not data being analyzed. And then we also saw at the end of last fall, also an increase in cases. And now with the Omicron variant, the cases are increasing a lot. But then you'd say, oh no, wait, we have to look at other data. Yeah, I agree. What other data in this case? Deaths, not just cases. Because now, throughout this last year, people got vaccinated. With the vaccine, they could still get sick from COVID, but they recover much faster. Is that true? This one, I had to jump from this one here. Yes, that's what the data suggests. New deaths in the US, in the previous waves, compare this one here. You had this wave, this one, third one. Here, you have all these peaks. And then you have this other one here, and you have this peak of deaths. And then you see, wow, now it's really increasing a lot. Would the deaths increase that much as it did here? No, because now a lot of people got vaccinated. But still, the number of deaths, again, let's remember, just when we closed the university after spring break 2020, and then in the fall 2020, everything closed, because how many deaths we had? Here. How are you now? Higher, even with vaccinations, right? So it's not a simple problem. And these graphs here are examples of aggregated level data. Since this is data collected from all these different countries through time, and they're summarized in this really easy way by this website. But when I compared this case here, I was just comparing the US to itself. But when I want to compare the US with other countries, I have to get the cases per population divided by the size of the population. But we still see that in the US, we even consider the size of the population, the number of cases is much higher than in other countries. Number of deaths. Then when you take death rates, when you consider the size of the population, then the US is not so bad compared to Russia, for example. But it's still in the higher levels than Mexico, Brazil, and India, okay? Percentage of fully vaccinated people. I like this graph. Look at Brazil. We passed the US. Say, more vaccination, less developed country, less money to develop vaccines, more vaccinated people, fully vaccinated, right? Even with the president that we have in Brazil, a new fascist guy that's completely against vaccination, says that he has not been vaccinated, but we have a public system in which people trust and people go there and get vaccinated and don't care what the president says, right? Past the US, that's awesome. I like this graph. Cool. And you might have heard throughout the pandemic this term, oh, we have to flatten the curve. This is the same graph as the first one that I showed here to you, number of cases, showing you only the US, not the 5 countries, only the US. And instead of just showing the new cases as linear, the number of cases, you just take the logarithm of cases. The logarithm kind of shrinks a little bit your data. And then the high cases get closer to each other. And what we want is that the cases here, after the pandemic started, after February, we would like this to be more flattened, that the new cases would either maintain constant, not increase a lot, or even decline. But you still see a lot of variation, right? So it's 12:25 now. It's time to finish. I don't want to pass through time. I will continue on this topic here on Tuesday. Okay, thank you very much and have a great weekend.